Okay. So remember, what we're looking at here is a cylinder that's had a rectangular prism or a square prism carved out of the middle, and we're looking for the volume on it. Now, the nice thing with composites and volume is they tend to be easier than surface area because I don't need to get all those additional surfaces on the inside. I can break this down as nothing more or less than just get the volume of the cylinder, the volume of the prism, and subtract them. Just take out what I've cut out. So, let's start off with that strategy. First thing I want is the volume of the cylinder. Volume, we said, is area of the base times the height. And in this case, the base is a circle. So pi r squared. And again, times the height. That'll give me the whole cylinder. Volume of the cylinder. CYL. So let's see, this is going to be pi times 3 squared times 5. Works out to be 45 pi.
Okay, you have to specify what you're going to do.
Okay, this case, you could theoretically stop at 45 pi, but I'm looking ahead in the problem. I'm going to be working with a square. And that square tells me I'm probably not going to be able to give my answer in terms of pi. So let's just not worry about trying to leave it in terms of pi. You could say, all right, I'm going to stop here at 45 pi cubic centimeters. And you're actually not in a bad place if you do that. The only thing that you run into is that later on I'm going to have a problem. So I'm going to go ahead and figure that out right now, just so I don't have to go back and get it later. If you're estimating your answer, you can also just take 45 and multiply it by 3. And that'll give you a pretty good answer. It's not great. 141.3. But it'll get the job done 9 times out of 10. Especially in general applications. Engineering, obviously, you wouldn't do that, but that's specialized. Now I got to worry about that volume of the box. The cutout.
Where's that decimal? Is it 141?
141.3. It's not a cube because I don't think it's 5 along one side, but it might be.
Wait. What back cutout are we talking about?
The middle square that's been carved into the cylinder. Yeah. Now, here's the kicker.
Oh, no.
I'm going to draw that box. This is the hole I've cut in the top of it. So if I look at the top of my shape, not too bad. It says this is a radius of 3. I need to get the area of that square given just that part of the diagonal. Now I know it's a square at least.
Yeah.
But the key is going to be, can I get the length of one side? So if the radius is 3, that's 3. How long is this piece? So the whole diagonal must be 6. And if I use the Pythagorean theorem then to look at this right triangle, that right triangle right there,
I'm not really feeling this.
let's call this x. X squared plus x squared is equal to 6 squared. 2x squared is equal to 36. X squared, therefore, is going to be 18. And x is, take the square root of both sides. Puts me at 3 square roots of 2. Or 4.6? 4.24. Now,
Yeah, I wouldn't be able to do that on my own.
well, again, this is where the challenge comes in. Most of the work in these problems is not so much on the volumes. It's on all these other rules that we're supposed to be remembering from throughout the year.
I know.
In fact, the 3 root 2, I'm looking at a 45, 45, 90 triangle, aren't I?
Once again, those are not my guys.
Yeah, they should be. It's supposed to have been. Here's the one bit of good news. We don't like on tests to have you guys draw back from too early in the year. We want to really test on the new stuff. We tend not to put too many of these on there. So either way, the area of that cutout, base times height, we're still not done. So 4.24 times 4.24, that's the area of that cutout, times its height, 5.
You can explain why the multiplied goes into this one by itself.
To get the area of the square,
So, how does that work?
4.24 is the length of one side.
Oh, yeah.
So that's just
You want the whole thing.
this piece right here, or this piece right here.
You want the whole thing.
I want the area of the whole cutout. So that's the 4.24 squared. It's a square. So I take 4.24 times itself, gives me around 18. And then we'll multiply that by 5. Gets me an answer of 90 square centimeters, or cubic centimeters.
But it was 90.
Where's this 5 coming from? How do you know it's a square?
I see all that right there.
Why is it squared?
No, how do you know it's a square?
Oh, because I know the diagonals are going to be equal to each other, and they're all right angles.
Oh,
Because remember, it's all built off that radius.
yeah.
And now I can go ahead and say, well, the final volume then of my prism is 141.3 minus the cutout, 90, puts me at 151.3, no, 51.3 cubic centimeters. Now there's one other way you could approach this one, which is that prism concept of taking the area of a base and multiplying it by the height, which means you start right on that circle with the cutout square, get the area of what's left. So area of the circle minus the square, and then multiply that value by the height of 5. You'll land in the exact same place. We'll end up with that area of just, let me color it in so you can see what I'm talking about. Just the area of this region here. That area is roughly just a pinch more than 10 square centimeters. That's the area of a circle, pi r squared, minus the square cutout. And then I can multiply that by 5, and that'll land me at a volume of 51.3.